Welcome to the 190th installment of Ear to the Ground, the Land Stewardship Project's podcast on family farming, sustainable agriculture, local food systems, and local democracy. I'm Brian DeVore, editor of the Land Stewardship Letter. I first met Dr. Kristine Nichols when she was part of the groundbreaking soil health team in Burleigh County, North Dakota. At the time, the USDA soil microbiologist was working with farmers, soil conservationists, and others to research and advance production systems that help the soil develop a biologically rich ecosystem. Through this work, farmers and ranchers in Burleigh County showed how a combination of no-till agriculture, cover cropping, and mob grazing of livestock could build soil organic matter, developing resiliency under some pretty harsh climatic conditions. What's particularly exciting about the work Nichols was involved in was that the farmers started to see a connection between healthier soil and healthier financial bottom lines. The work of this team has been a major inspiration for the recent widespread interest in building soil health on agricultural lands. What impressed me about Dr. Nichols, who is now the chief scientist at the Rodale Institute, was that she was willing to admit that the farmers she worked with were leading her into new scientific territory. Some of the results these farmers were getting as a result of their efforts to build organic matter literally sent Nichols and other scientists back to the textbooks to figure out what was going on. The Farmer-Scientist Partnership is one of the reasons the Burleigh County Soil Health Team has been so influential, both in this country and abroad. Nichols recently presented at a soil health workshop sponsored by the Land Stewardship Project in southeastern Minnesota. Over 140 people crowded into a basement meeting room to hear Nichols and a panel of local farmers describe how building soil health can increase the agronomic, environmental, and economic resiliency of a farm. In this podcast, we feature an excerpt of Dr. Nichols' comments from the workshop.
But really what I want to look at is this whole idea of utilizing soil biology to basically build up resilience. My dad is a farmer in southwestern Minnesota, and he's here today with me, so he's also my driver when I come to Minnesota, and I'm always grateful to be able to come back to Minnesota. I really enjoy being back in Minnesota. Essentially, what we're looking at in being able to have, as a farmer's daughter, one of the things that I realized was that the only certainty that you have in agriculture is that the weather's going to be uncertain. It's the only thing you can depend on, right? Nothing else you can really depend on. So what we're trying to do is we're trying to create these systems that are going to be able to respond better to the uncertainty of weather. And as weather becomes more and more uncertain, and that's a lot of what we're finding, is that weather is becoming even more uncertain. We have periods in areas of the country that are experiencing, we don't get day-long gentle soaking rains anymore very much. We get these heavy deluge of rains, and we get long periods of no rain between that. So how can we still be able to grow crops? And that's really what we're looking at, is building up soil health in order to be able to do that, and how that's going to basically regenerate the entire system. And what you're really looking at is, with healthy soil, is this continued capacity to function. That's that resilience that I was talking about, that it continues to provide what the soil is innately going to provide for us. The soil, the organic matter in the soil is the ultimate filtration system. We can't have clean air and clean water without having healthy soil, having that organic matter that's in the soil. That's how you're going to have clean water in your nearby creek or pond or whatever it is that you may have on your field or nearby your field. It's how you're going to be able to make sure that you're not going to get huge dust clouds that are going to be happening. You're going to be able to have that good soil structure that's going to keep the soil in and on the surface and below the surface, as opposed to it blowing in the air. So we're going to be able to have this continued capacity to function. And the other thing is that we want the soil to provide our nutrient needs. A lot of what we're doing at the Rodale Institute is looking at ways and working with farmers. Before I moved to Rodale, when I was working with farmers in North Dakota, looking at ways in which we could satisfy the nutrient needs for our crops and the water needs for our crops by having healthy soil. Because those nutrients that your crops need are in the soil environment. We add these chemicals to our soils where the biology would provide these things. The biology has been working with the plants for over 400 million years to try and create these relationships. They have optimized the efficiency of being able to get those nutrients when the plant needs them. And so what we want to do is we want to have healthy soil so that we can also have healthy food. One of the things that we're really starting to see is the fact that we're actually in this country confronted by obesity, an obesity epidemic that's really caused by malnutrition. We are malnourished and obese as a country. That doesn't make any sense. You go to third world countries and they'll look at you and say, why are you obese and why are you malnourished? You live in this very wealthy country, how can this possibly happen to you? And it's because the food that we're eating doesn't contain all of the nutrients. One of the things that happens when we rely on the biology in the soil to do a lot of this for us is that we're going to get all of the micronutrients and other types of beneficial biochemicals, things like antioxidants. So that's really what we're trying to do is, you're all in the business. Again, my dad's a farmer. I'm proud to be a farmer's daughter because you're in the business of feeding people. Part of what's happened is that, unfortunately, you guys got sold a little bit of a bill of goods in a cookbook that told you to apply certain types of chemicals and certain types of pesticides that, yeah, you're feeding people, but you're not really feeding people the food that people need to eat. And so what can we do to be able to change that? How can we have healthy food and healthy people? And how is that then going to extend to a healthy planet, to clean air and clean water? The things that we want to have for our kids to be able to grow up on. So what we're finding is that part of the problem with this unhealthy soil is really tied to carbon that's in your soil. And so that's why I passed around those jars, because that's measuring the carbon that's in your soil. That's basically a way of looking at the idea of how much carbon is in your soil, because the microbes are going to be eating that carbon and then they're going to respire just like we do. We give off CO2 and then that gel measures CO2. So that's what's going to be happening in the system. So what we want to do is we want to get more carbon in our soils. And by having more carbon in our soils, I think of carbon as the currency. This is the money. This is your cash money that's working in your system. This is how everything is functioning. Almost all life on planet Earth is carbon-based. Major exception to that is diatoms, diatomaceous earth, or silica-based life forms. But everything else is pretty much carbon-based life forms. And so that carbon comes into the system from CO2 in the atmosphere and sunlight energy through the plants and photosynthesis, converting that carbon into sugars that's then going to go into the soil environment and into the plant tissues and the plant leaves and the plant roots and the plant grains and all of the things that you have there. And so when we have carbon and we get more carbon into our system, we're going to have more biological activity. We're going to have healthier people. We're going to increase our water infiltration rates. We're going to get water into the soil much more quickly. We're going to hold on to that water for a longer period of time. So it's going to become available to the plant when the plant needs it. And then we're going to be able to have better soil structure so we don't have so much erosion. We're going to have better fertility. We're going to be able to take advantage of the nutrients that are in the soil as opposed to having to buy those nutrients. Nothing is free in an ecosystem. Everything costs. The difference is either you pay the cost for the nutrients and you pay the cost for the fact that you have erosion and you pay the cost for pollutants that get into your lakes and rivers and streams, or you require the plant to pay the cost via carbon to the soil biology. Why don't we let the sun pay the cost? That's what we're trying to do, is utilize the energy from the sun as opposed to your energy, your work, that went into you getting cash money to buy all of the things the biology could give you. So how is it that we're going to have to do that? And that doesn't mean that there isn't a little bit of work that you may have to put into it, or different type of work. A lot of the farmers that I work with actually say that they have a lot more time on their hands. They're not working harder, they're working smarter. So they've got a lot more free time to be able to do a lot of different things because they're relying on these systems to work for them. So what we've seen, this is some data from our farm in Pennsylvania, but we can see these same things happening throughout the country. So I've got some examples from different areas. So in our farm in Pennsylvania, we are an organic farm. So our two organic systems are an organic manure-based system and an organic legume-based system. We don't add even any organic inputs to that system other than in the manure-based system, we add organic composted manure. And we also use legume cover crops and legume crops in the rotation. But we don't add any other organic amendments to that soil. We also don't add any organic pesticides to the system. So it's all working with the things that are in that soil environment. The conventional system is a typical corn soybean rotation that you would have pretty much across the country. We usually utilize about 150 pounds of N. We have pretty high phosphate soils, so we only put on roughly about 50 to 60 pounds of phosphate a year, depending on where we are in the rotation. And then we utilize herbicide to burn down to manage weeds. We use the GMO varieties of crops. So we have triple stack corn. We've got Roundup Ready beans in our rotation. And again, it's a corn soybean rotation that you've got there. And the thing that we've seen, again, is that we're increasing the amount of soil organic matter. This experiment is going into its 37th year of continuous production. So we've been doing these side-by-side comparisons. And in our conventional system, the organic matter, the A horizon, goes down roughly about 10 inches. But in our organic system, in our organic manure system, we have it going down anywhere between about 12 to 20 inches. So not only can we increase organic matter at the surface, but we can increase organic matter further down in the soil. We're growing soil from the top down, utilizing the energy of the sun. This is what we want to do to be able to regenerate, to revitalize the system, to be able to have healthier soil and that continued capacity to function. That's what it is that we're looking at doing. But part of what the other thing that we're seeing is it's not just a color difference, but it's also a structural stability difference. And so if we take a clod of that soil and we put it into water, and these are the things that I would encourage you to do. Some tests that you can do to be able to get an indication for how healthy your soil is. Being able to get an idea of what's happening. Go out there with a shovel. The best tool in agriculture is a shovel. If you don't have one, go out and buy one if they're cheap. You don't have to have a really fancy one. Any old one will do. In fact, in some cases, I go out there with a garden trowel. Don't have to put a whole lot of investment in your shovel, but invest in a shovel. Go out there and take a look at what's in your soil. Feel it. See how well it crumbles. Feel how well it may stick together. Feel how well it feels. Smell it. Take a look at how it looks. What color is it? And then take a spot in your field or go over to a neighbor's farm that may have a little bit, may not be doing as well with his management as you are doing, and go over there and take a look at what his soil looks like. Take a chunk of the soil and put it in a bowl with water. These are just fish bowls. Any bowl will do. Put it in there, fill it up with water, drop the soil in there, see what happens. How well the soil is going to stay together. That's what you're looking for, because the soil that's going to stay together is soil that's not going to erode. The soil that's going to stay together is going to filter water better. The soil that's going to stay together is going to be able to cycle the nutrients that are in the soil and provide those to the plant. The soil that's going to stay together is going to hold on to that water between rainfalls so that the plant, even when you have drought periods, the plant's going to be able to flourish. That's what we want to do with the system. So, water use efficiency. Again, I said the only certainty that you have is that climate is going to be uncertain. Weather's going to be uncertain. We want to be able to utilize water most efficiently. If you do those things where I said the soil's going to stay together, that's going to increase porosity. If you increase porosity by just 45%, you can increase the infiltration rate of the first inch of water by 167%. And a second inch of water by 650%. So again, when we had those day-long gentle rainfalls that you would have, I remember when I was a kid and you had those days that you just had it just rained all day, nice and gentle. You got time for the water to infiltrate. But if it's going to come down heavy, most of it's going to run off, right? You're going to get ponding in your fields. So we want to be able to manage water better. If you increase the amount of organic matter that you have in your soil, you can increase the water holding capacity. You increase it from 0.5% to 3%, depending on the soil texture, you can double the water holding capacity. Now that doesn't happen in a linear relationship. It's not going to keep happening, but you are going to continue to increase the amount of water that you're going to be able to retain. And water holding capacity means that it's going to keep a hold of that water between those rainfall events. So what happens when you have the porosity is it's open space between the clods that are in soil. We call them aggregates, these little pellets that are inside your soil. You're going to have open space between those pellets because they can't fit together real tightly. So you're going to have open space, and the thing is the path that water has to take to go around that, it has to bend and curve. It's like a long, curvy road. And the advantage of that is that there's more space in a volume of soil. So in a depth of soil, you go down maybe you're going to go down about 8 inches in your soil. If the path was straight, the amount of water that you could hold in a straight path as opposed to the amount of water that you hold in a curvy path. Think of that. If you take a straight road, if you take the interstate to someplace, it's less miles. Not only can you go faster, but it's usually less miles than if you took the curved path, because it's more area that gets to be filled. So now you can fill more in that certain depth of soil. The other advantage to this with water holding capacity, so that's infiltration. You're going to get more infiltration rate because you have more space in that area to be able to get more water in. Water holding capacity is because it has to bend and curve and move around those aggregates that are there instead of a straight path, means that water is constantly being pulled out of the surface of the soil by sunlight energy, by heat, and it's constantly being pulled down by gravity. And those two forces are going to remove the water very quickly when it's in a straight path. But when it has to bend and curve, it's like getting a drink and putting kinks in the straw. If you have a bend in the straw of your drink and you try and shake a drink, and then, it isn't working, and you're going to go, and then you go, and then you go, forget this. And you're going to just drink right away, right? Because the straw just doesn't work that way. That's what's happening, is that it's going to take more prolonged heat or more high temperatures to evaporate the water off the surface, or more time for gravity to pull that water out. So even if you have periods where you don't have a rainfall event, you can still have moisture in that soil. So this is in North Dakota. This was at Gabe Brown's ranch near Bismarck. This is in this environment. This is central western North Dakota. Our average rainfall up there was about 14 to 16 inches. This was in 2009. We had a rainfall event that was 13 inches in about a 24-hour period. Came down, you thought you were in a tropical rainforest. Just dumped on us. This is his soil the next day. Very little residue removal, no ponding. Could walk out there, didn't even have to, wipe off your boots when you came back in the house, because you weren't getting mud on your boots. He has taken his infiltration rate from a ½ inch per hour in 1991 when he started on the farm to over 8 inches an hour by 2011. So in 20 years, he increased his infiltration rate from ½ inch to 8 inches. It's possible to do these things. It doesn't mean that you're going to be able to do them right away. A lot of people ask me, because I'm a soil biologist by training, and they're like, okay, what inoculum, what bugs should I buy? How can I get the best bugs? Who do you know that can sell me the best bugs? Give me the number. I can't do that for you. I won't do that for you. So the point here is that you want something, you want to buy something that's going to change this in the season. You need to see it right away. You need to buy the bug in a jug. You need to be able to apply some sort of chemical. You need to be able to have these immediate results. And that's not what's going to happen when you have to wait for the sunlight to pay for this system to function. It's going to take time, especially because we haven't been working this system for decades. So it's going to take time to be able to restore this, to be able to regenerate it. Once it gets regenerated, it's going to work fast. It's going to be able to do these responses. Now, in the organic system, what we had biology that was locking up those nutrients in the bodies of bacteria and fungi. And we had fungi that were creating a pipeline between the soil and the plant roots. The mycorrhizal fungi were doing this. And so, when the plant started to have its nutrient needs, it gave off exudates that said, I need nitrate and phosphate to the soil. It's like a language. It's like what happens in your body. Your body, you stub your toe. It's a chemical reaction. Chemicals are released where you stubbed your toe in that area, and they send a signal to your brain that says, say ouch. So you say ouch. The plant releases chemicals that say, I need nitrogen. The microorganisms in the soil say, okay, give me carbon and I'll give you nitrogen. Pay me and I'll supply you. So what happens is then you have other organisms, you have things like protozoa and nematodes that eat the bacteria and fungi and release the nitrogen that's in their bodies, so that nitrogen can then go into the plant. And then you have the mycorrhizal fungi that instead of the roots having to leak off a whole bunch of water to create a water film, the mycorrhizal fungi are already pipeline that's in the soil that will go out there and pick up those nutrients and send those nutrients back inside the plant roots. It's a highly efficient system. Works far better than adding the chemicals to the system. So this is what it is that we want to be able to tap into. So really, drought stress is often not really about water as much about nutrients and how we're going to manage nutrients. And that's what Albrecht's study basically showed, that you could use a lot less water if you had better fertility. We're just going to apply the fertility naturally to the system. So that was in 2015. We saw this again in 2016. Organic corn this time had almost a double yield, twice the yield. We had about 200 bushel organic corn and about 100 bushel conventional corn. So this is the other thing that kind of happens. Our organic corn or organic soybeans are here. You can see the nodulation that you will have on here. You're going to have a lot more nodules. We have a lot more fine roots, and we have nodules that are on fine roots. That's that bacteria, that rhizobium bacteria, that is fixing nitrogen, taking the N2 gas and converting that into nitrate. In the conventional soybeans, we do have nodules, but they're mostly just right here on the taproot. And what that's going to do is that may help this legume, help the soybeans grow, but it provides very little nitrogen to the rest of the soil environment. So one of the things that we've always done when we've given N credits to a legume crop is we do it based on above ground biomass and the amount of nitrogen that you would expect to have in the C/N ratio for that above ground biomass. That's how we calculate N credits. But actually what's happening below ground can be far more important, and how much nitrogen you may have available to subsequent crops will be some of this nitrogen that's going to come out of these roots as these roots are broken down. But in this case, you're not going to have any more nitrogen. So you're dependent upon all of the nitrogen that was above ground. Whereas in this case, you can utilize some of the nitrogen that was above ground, but a lot of the nitrogen that was below ground for your subsequent crop. And so we're just starting to kind of try and get an assessment on how we're going to redo N credits for crops, looking at this below ground component and not just at the above ground component. Essentially, this was a little bit of what I was trying to say before, is this whole idea of the fact that we lose approximately 30 to 50% of the nitrogen that you add. I don't quite understand this. I've gone around the country and I brought this up many times, and I don't really understand why you guys really don't go and revolt. Because you basically pay 100% of the cost for a product that you know you're only going to get 30 to 50% of the efficacy of. Now, I don't know about you, but those economics don't really work for me. If something's only 50% good, it's only going to give me a 50% reward, I want a 50% discount. And it's because we're going to be adding those nutrients to the plant when the plant can't use them. I talk about this as sort of like a big buffet. So you're going to go to the buffet and you're going to eat all of this stuff, but you can only eat so much. The plant, when it's little and we add these fertilizers to it, or the fertilizers were added the fall before, or even before the plant even germinated, there's only so much that can be taken up by that small plant. But we added everything it needed for its whole entire life cycle at that time. To the plants, we give them the big buffet maybe once or twice, at most 3 or 4 times throughout their growing cycle. And we expect them to be okay and to store those nutrients and to keep them, to be smart enough to spread out the buffet. The plants evolved with a system that they worked with the organisms that were in the soil that provided them the nutrients they needed when they needed those nutrients. So there was nothing that they had to wait for the buffet to be able to do. So what has happened over this time is we have decoupled, we have outsourced the job of the microorganisms, the biology in the soil, to your pocketbook. It's not economical for you to do that. And the more you outsource their job, the fewer of them there are. So what we want to do is we want to rely on relationships like this. These are the mycorrhizal fungi. This is actually the root. These fungal hyphae go inside the root. They create these highly branched structures inside the roots called arbuscules. And they'll go out here in the soil and create highly branched structures where they can pick up the nutrients, take them through the pipeline inside the roots, and drop them off at the front door. So sometimes, too, it isn't always just, again, looking at organic or looking at the farm practices that we're choosing. Everything is on a spectrum. So everything that it is that you're trying to do is either taking steps forward or taking steps backward. And you're going to take some steps backward. You may do some tillage, you may do some application of an herbicide, you may do some application of some chemical fertilizers. You may take some steps backward. But what I want is for you to always be taking some steps forward, and for forward momentum to happen. And the other thing that I always ask when I give talks to groups like yourselves is I never, ever, the one thing I ask you to do is to never say I can't. I have farmers I work with that grow cover crops near the Arctic Circle, or doing no-till and cover cropping near the Arctic Circle. You're in southeastern Minnesota. It's not too cold and too wet here to do that. You can't say that you can't. It may not be the path that you think that it would be. It may not be the easiest path, but you can get there. You can do these things. This can happen. So what we need to do is we need to have a brown revolution. We don't need a new green revolution. We don't need new genetics. What we need is we need to be able to regenerate and regrow our soils. We don't want to do things sustainably. We lose 2 billion metric tons of topsoil in this country every year. If we were just doing things sustainably, we'd just continue to do that. We don't want to sustain bad. That's what sustaining does. We want to regenerate. We want to revitalize. We want to go beyond where we are currently. So the way that we're going to do that is we're going to minimize soil disturbance. We're going to reduce the amount of tillage that we have in the system. We're going to energize the system with diversity. So we're going to have a more diverse crop rotation. If you're just into corn, soybeans, I understand the economics of corn, soybeans. I understand the economics of corn sometimes, some years. You can add diversity through a cover crop. So if you're missing diversity in your crop rotation, please add diversity in a cover crop. If you're missing diversity in your overall system, try and add diversity through multiple enterprises. If you can include livestock, include a perennial phase in your crop rotation. It's one of the things that we're starting to do a lot more of, is putting a perennial phase and graze that perennial phase that you have there. We can get 2 to 3 times the amount of forage biomass when we're grazing, and also be putting a lot more carbon below ground when we're doing grazing. We want to be able to keep the soil covered, keeping the residue on the surface, putting residue in the soil. So someone asked about tilling in a cover crop as opposed to rolling it down. You don't actually end up gaining that much in fertility by tilling it into the soil, because the majority of your fertility is already below ground in the biology that's there. And when you do the tillage, that destroys their habitats. So what you want to do is that you want to utilize where there's the greatest asset in that soil environment. If you till that stuff in, you may gain a little bit in the short term, but it's not going to be able to offset what you've lost in that soil environment. And it's a very short-term flush of nutrients when you do that tillage. And that also can be a little bit of a problem, because you do that tillage, you provide those nutrients like the big buffet. It's like adding synthetic nutrients to the system. So keeping the soil covered and protected is much more advantageous. Just a gentle rainfall hitting the surface of the soil on a per acre basis is equivalent to 8 tons of TNT. You basically, when it rains, you're exploding the soil surface. If you have residue on that soil surface, you've basically diffused the energy of those raindrops before it impacts the habitat of the microorganism. Tillage can be a wrecking ball, rain can be a wrecking ball, going through those little microbial towns that are inside the soil aggregates. The most important one that I think that's out there is maximizing living roots. Keep something growing as long as possible. We are in a carbon-based system, carbon economics. Best way in which you're going to be able to pay for the system is by putting more carbon in the soil. And that's going to require you to have a living crop, living plant. And adding livestock to your system is also a great way of being able to maximize the efficiency of the system. It doesn't mean that you all have to own cows. You can add other types of livestock to the system. You can work with a neighbor or someone else to be able to do a little bit of grazing on your system. Or there's a lot of advantages that insects give us. And insect grazing, the plants need a little bit of stress to perform most efficiently. Think about yourself. Every organism is lazy if it can be. Least amount of work for the most amount of reward. That's the way we want to function. It's genetically programmed into all of us. It's in our genes. You can't fight that. The thing is that you also know that in order for you to be healthy, you need to do a certain amount of work. A good athlete won't run the same distance in the same time or lift the same amount of weights, the same number of reps all the time. because they need to keep adding more stress onto the system in order to maximize the way in which their body can respond to that. A little bit of grazing by an animal or a little bit of grazing by an insect is actually a little bit of stress on the part of the plant, and those wounds will actually require the plant to give off more carbon to the soil to get the minerals to cover up those wounds, but also that's going to provide more biological activity and more fertility and minerals when the plant needs it in the future. It's a way of being able to work your system.
For more on the Land Stewardship Project's work related to helping farmers build healthy soil in economically viable ways, see our website at landstewardshipproject.org. There you'll see a series of land stewardship letter articles on the Burleigh County Soil Health Team. If you have comments or suggestions about this podcast, contact Brian DeVore at bdevore@landstewardshipproject.org, or you can call 612-722-6377. Thanks to Laura Borgendale, a Western Minnesota musician, for Ear to the Ground's theme music. And a special thank you to all of Land Stewardship Project's members who make initiatives such as this podcast possible. If you're not a member, visit landstewardshipproject.org to learn how you can support LSP. Thanks for listening.